Okay, Mr. Keller, this is the second in a series of 2 videos containing the corrections for WebAssign test number 7. This will continue with number 13, which asks the coil of area rotating perpendicular to a magnetic field. What is the maximum EMF generated within it? So you start with the equation that the Emax is equal to the number of turns times the area times the field times the omega. You're given that the number of turns is 800 times the area, which is given as 0.1, the field, which is given as 0.2, and the omega, which is going to be the number of turns times 2 pi. So you're going to multiply all those together and end up with 5,026.54. By the way, I've done all these calculations beginning at whatever. I've already done them all for terms of expediency, so I'm just explaining them all to you now. So the next one was number 14, which asked it gave you a circular loop of wire within a uniform magnetic field. The magnetic field varies with time according to the equation B equals A plus BT. So what you're going to end up with, it then asks for these 4 different variables or things that you're solving for. It asks for the equations of both those. So the flux generated within this is going to be the area times the field, which is just going to be pi r squared times b times t, pi r squared, a plus bt, pi r squared, a. The next one you're looking for is going to be the E, which is going to be just negative d flux over dt. Again, you just add the negative sign in front and change the variable around to get pi r squared b. C is just going to ask for the current, which is just going to be pi r squared b over r right here, and the D incorporates that current equation asking for power, which is just going to be used as I squared r. I, again, written as pi r squared b over r times r, and you're going to multiply that together to get pi r squared b squared over r. So that is number 14, those 4 equations that it asks you for there. Number 15, moving on, asks you it gives you a rectangular coil with a number of turns with an angular speed, and you're supposed to find all of these 4 different things. It asks you first for the Emax, which is just going to be the number of turns times the area times the field, and that's going to be 63 given as the number of turns, the area given as length times width, 0.1 times 0.2, the field, which is just going to be 0.1 times the rotational speed, which is going to be 28. Then you're going to multiply that all together to get an Emax of 35.28 volts. So that is that. Number letter B, moving on, it asks you for the change in flux, which is just going to be the field times the area times the rotation again. That's going to be a given field of 1 tau times the area, which again is just length times width, 0.1 times 0.2 times that 28 radians per second, which is going to be multiplied together to give you 0.56. The E is going to be given to you again as Emax times the sine of alpha times t, which again you take this 35.28 which you found up here, multiply it by sine of 28 radian per second times 0.05 and end up with an E of 0.86. The last thing it asks you for here is the torque, which is going to be the number of turns times the area times the field times the length, which is going to again is going to be given as 63 times 0.1 times 0.2 times 1 times 0.2, and is going to give you a torque of 0.252. So that is WebAssign test number 7, David Engell corrections.